Hi, fifth grade. Today we're going to be doing Module 4, Lesson 4, and we're going to be continuing with dividing fractions, except today we're going to be doing some word problems, and instead of doing the models that we have been used to, we are also going to be doing tape diagrams, so we're going to be going back to that for a little bit to show our work for these division problems. So let's get started with the problem that I have up on the board right here. So we're going to be doing this problem which says 8 tons of gravel is equally divided between 4 dump trucks, and how much gravel is in 1 dump truck. So what we need to do is first we need to find all the important information in this word problem so that I know what I'm trying to solve, what's important information to help me solve that. So I'm first going to start with 8 tons because that tells me how much I have of something, and it's telling me that it's equally divided, so that tells me kind of the keywords that are going to tell me what kind of math I am going to be doing. And they're being divided between 4 of these dump trucks. And then overall, I need to find out how much is in 1 truck. So that's going to kind of give me an idea of where I should be starting. So if I have 8 tons of gravel and that is being divided between 4 dump trucks, what that means is I am doing 8 divided by 4, because I have 8 tons of gravel divided amongst 4 trucks. Now, normally if we were to do a model for this, I would have to draw 8 models, break them up into fourths, then do work from there. And when we get into these numbers where we have a larger number up in front that needs to be divided up, it becomes a lot of work. So what we're going to do today is we're going to create something called a type diagram, and this is going to be a good thing to use when we have these bigger numbers because it's a little bit easier to visualize. So what I'm going to do is a tape diagram is like a long rectangle. So draw a long rectangle on your desk or in your notebook as well. And what I want you to think about is you're going to create a little semicircle. And what I want you to think about is that this whole thing right here is my 8 tons of gravel. So we're at 8 tons right here. So this whole thing equals 8 tons. And now what I have to think about is okay, well, I have 4 trucks that I'm dumping it into. So this bar of 8 tons is no longer just in 1 truck or 1 place. This is now being divided up into fourths. So I need to break up my model into fourths as well. So I do that by just breaking up this thing into fourths. And now I am showing you what 8 tons being divided into 4 would look like. And now I just have to think about, okay, well, if I have these 8 tons divided into 4 sections, how much can go into each section? So in this case, I could think of that as, well, I can count by 2s and get up to 8. So 2, 4, 6, 8, and that definitely works right there. So I know that 8 tons being divided by 4 would equal 2 tons per truck. I can write that right here. 2 tons per truck. And that would just be all I need to do to solve this problem. Yes, you might know what 8 divided by 4 is right on top of your head, and that is fantastic. But we also want to draw models to kind of show or prove why that is. So remember, this whole model used to be 8 tons on its own. Then we broke it up into fourths, and we showed how much is going to each section. So that is our first problem for today. I'm going to pause the video and get our next word problem up, and then you can go ahead and erase all of this while I'm doing that. All right, so back with the next problem. So our next problem is 5 tons of gravel is now being equally divided between 4 dump trucks. How much gravel is in 1 truck? So this is where things get a little bit more difficult because I know how to do 8 divided by 4. That's an easy problem for me to do. But now that I am dividing, what I can assume is going to be 5 tons being divided up into 4 dump trucks equally. I'm trying to find out how much is 1 truck. Now it's going to be a little bit more difficult because now I have a problem where it wants me to do 5 divided by 4. And just knowing, using my number sense, I know that this is not going to divide evenly like the previous problem just did. But I'm still going to try and use this tape diagram to help me out. So again, I'm going to start off my tape diagram by just drawing a long rectangle. So go ahead and draw your nice long rectangle. And then I'm going to label this as 5 tons. So this entire thing, imagine this is like a big pool of gravel. Imagine this whole thing is filled up with 5 tons of gravel. And what I need to do now is I need to divide this by 4. So I need to split this model into 4s to show what that would then look like. So just like the previous problem, I'll break this into 4s by drawing those 3 vertical lines. And now I have my model broken into 4. And now what I need to do is I have to think about, well, if I have 5 divided by 4 and I'm trying to figure out what one truck is, what I need to do now is I need to figure out what does this one space equal. Now before that was really easy because I know that if I keep counting up by 2s, that would get me to 8. But how do you count up to 5, but you're still doing it equally? And that is where our fractions come in so that we can do that. So to find this space right here, I know that this space right here, to figure it out, I have to figure out what 5 divided by 4 is to figure out this one unit. So to do that, I'm going to set up a standard algorithm. So I'm going to say it 5 divided by 4. And now I can start solving now that my problem is set up correctly. So if you want to, you can probably just do this problem on your desk and then work along with me. So 4 goes into 5 one time. So I put a 1 up here. And then I need to multiply. So I do 4 times 1, which is 4. And then I can subtract. So now I have 5 minus 4, which is 3. And this is actually going to leave me with my final answer, even if it might not look like it. Because with all the numbers right here, I can create a mixed number, which will give me my answer. So what I need to do now is I need to find my whole number. And my whole number is 1. I always start at the top. So my whole number is going to be 1. And then my remainder in this problem is this 3 right here. So that is my numerator. And then my denominator is what I'm dividing this by, which is 4. So my final answer would be 1 3/4. So this unit right here, this question mark, is actually 1 3/4 tons. And I could check my answer because if I were to add 1 3/4, 1 3/4, 1 3/4, I would get 5 eventually. So you can check your answers like that if you would like. So just how I had all those 2s in that previous problem, I can have 1 3/4, 1 3/4, 1 3/4, and 1 3/4 like this. And if I really wanted to, I could add all these fractions up together, especially because they have a common denominator. It shouldn't be too difficult. And that is how we would solve this problem right here. So very similar to the previous problem, just the only difference is that after I cut up my model, I knew I couldn't evenly divide it by just using whole numbers. So I used my standard algorithm to help me figure out what my mixed number was going to be. So I'm going to pause the video again, get up our next problem, and go ahead and erase or get ready for the next problem on your own as well. Hi, fifth grade. So the previous problem, I made a little bit of an oops. So if I have 5 divided by 4, 4 goes into 5 one time, that would be 1 right there. 5 minus 4 is definitely not 3. That is definitely 1. So my final answer is 1 1/4 tons. So that should be my final answer. If I checked my answer, actually, I would have figured out that I got that wrong. So check your answers. Make sure you don't make mistakes like this comes to. But this should be your final answer for the previous problem we just did. So, and you might have already caught me on this. So let's take a look at this problem. Hopefully I don't make any more mistakes. And what this problem is asking us to do is it says a 3-meter ribbon is cut into 4 equal pieces to make flowers. What is the length of each piece? So I'm going to go in and pick out that important information. So I have a 3-meter ribbon. It's being cut into 4 equal parts. And I had to find the length of each piece. So in order to do that, I have to create a division problem out of this, because if I'm cutting it or trying to make equal pieces, usually that is a signal word that I am trying to divide. So to do that, I'm going to have 3 divided by 4. So I'm taking those 3 meters, I'm cutting them up into equal pieces so that I can get enough for each bundle of flowers. So I'm trying to find the length of each of those pieces. And remember, like I said, yes, normally I could draw 3 models, cut them all up, and I would get 12 fours, and I would divide that. But the area model kind of just lets us visualize what's happening without having to do as much work. So again, I'm going to draw my tape diagram, not area model, tape diagram. And what I'm going to do is I'm going to label my tape diagram. So this whole thing equals what my first number is. How much do I have? So I have currently 3 meters of ribbon. So I have 3 meters of ribbon. This whole thing represents that. And I need to break these into 4 pieces that are equal so that I can tie them around the rest of the flowers. And to do that, I am going to cut this model into fourths. And now I have to think to myself, well, I know with my number sense that I can't easily divide 3 into 4. That doesn't really work. I'm going to get some sort of fraction, and I don't really know how to count up by that. So what I'm going to have to do is I'm going to put this little question mark right here, and I'm going to think about, well, what does this 1 unit equal? And to get that answer, and you should be able to start this off on your own, is set up a standard algorithm to help you solve it. And this is basically what you're going to be doing on most of the problem set and homework set, is you're going to figure out what the problem is asking you to do, create your division expression, create your tape diagram, and then show me your work with a standard algorithm. So right now I have 3 divided by 4. So I have this problem right here. And then after that, I have to start dividing, and I have to figure out what do I need to do from here. All right, now when you get to this, you're going to start thinking, well, I can't do 3 divided by 4 like this. So what do I do now? Because yes, I could add a 0 and all that, but that wouldn't give me the correct fixed number or answer that I am looking for. So in situations like this, sometimes you're not always going to have to do your standard algorithm. So you always want to try and do the standard algorithm, but if you get in a situation where this number is bigger than this one, then you can actually just look at your division expression and think about the lesson that we learned from lesson 3 and how we can use the division expression to help us create either mixed numbers or improper fractions. And that's actually what we're going to do right here. So we're going to do away with the standard algorithm just for this problem. And I'm going to think about, well, if I have 3 divided by 4, then I can write this as an improper fraction, like I did back in lessons 2 and 3. And all that needs me to do is I basically just rewrite this with this number 3 in my numerator and this number 4 in my denominator. And this improper fraction is basically the same as that. But remember, this can also be considered one of my answers, because think about those models that we did. Usually I did those models so I can understand how I got that number. And this number right here actually works perfectly with this. So this question mark right here actually does equals 3/4, and the rest of these equal 3/4. And just so I don't run into a problem like I did last time, I'm going to add all this up to show you how to check this. So I have 3/4 plus 3/4 plus 3/4 plus 3 plus 3/4. Or I can also do 3/4 times 12. You could also do that. So I'm going to keep it like this. So I'm going to count this up. That's 4. Count by 4. So 3/4 times 4. And then I get 12/4. Or I could do it as this. So I have 3, 6, 9, 12 over 4. And then I think about, well, what is 12 divided by 4? 12 divided by 4 is 3, or if you need to use a standard algorithm to solve that, you could also do that as well. So how many times is 4 going to 12? 4 goes to 12 3 times, and 3 work like that. So that is how you can check that answer. So sometimes the lesson from this problem is sometimes you have to do a standard algorithm, sometimes you don't. I'm going to erase this and move on to our next problem, and then after that we'll go over your problem set. All right, so we're on our very last problem now, and for our last problem today, we're going to switch it up to fish tanks. Oh my gosh! And for this problem, we have 14 gallons of water is used to completely fill 3 different fish tanks, and we're just going to assume that all the fish tanks hold the same amount of water. So how much will each tank hold? So right now I know that, and I want you to try this problem on your own, and then watch me explain it. But I know that I have 14 gallons of water that I could totally use to fill up these 3 different fish tanks. And I'm trying to figure out how much is in each of these tanks. So I'm assuming by this point you have tried to figure out what you need to divide, and you're just working along with me right now. So for this problem, I have 14 gallons, and I'm dividing those 14 gallons among 3 fish tanks. So I am going to have the problem or the division expression 14 divided by 3, just like that. Now I know that if I were to write this as an improper fraction like that, it would be 14 over 3. So I am going to use my tape diagram to help me understand what this problem is going to look like. And then I'm probably going to use my standard algorithm to solve because I don't have a finished number right there. So to draw my tape diagram, I'm going to draw my nice long rectangle. And I'm going to need to cut this rectangle up. And remember, this whole tape diagram equals 14 gallons right now. So it's kind of like I had a big pool with 14 gallons. And now I need to pour it into 3 different fish tanks. So since I'm dividing it between 3 fish tanks, I'm going to be cutting this into thirds. And I need to figure out what does one of these tanks hold so I can figure out what each of them holds. And to do that, I can set up a standard algorithm this time. So I have 14 divided by 3. And now I can start solving. So 3 does not go into 1, so I'm going to skip over to 3 into 14. How many times does 3 go into 14? Well, I could do 3 times 4, which is 12. So I'll put a 12 or 4 up there, and then I multiply. 3 times 4 is 12. And then I need to subtract. So I do 14 minus 12, which is 2. And then I'm going to stop right there. So what I got from this is I'm eventually going to be able to piece all of this together to get my mixed number. And what I get from this is 4, because that is my number at the top. That is my whole number. My remainder is my numerator, so that is 2. And then my denominator is 3. So my final answer is going to be 4 2/3 gallon. Now, since I don't want to fall into the mistake that I fell into before, I am going to check my answer. So I'm going to give myself a little bit of space to do that. And remember, you should have already gotten this answer. Try to work on this on your own. So to check your answer, remember that you're going to have 4 2/3 plus another 4 2/3 plus another 4 2/3. And you're trying to make sure that it all equals up to 14 gallons. So we're going to do some repeated addition to see if this all makes sense. So my first step in this, just like the problems that we have done back when we were adding and subtracting mixed numbers, we always want to work with the whole numbers first. So I have 4 plus 4, which is 8, 8 plus 4, which is 12. So I know I have 12 plus 2/3 plus 2/3 plus 2/3. So I know I have these numbers, and now what I have left to do is to add up all of these fractions. Thankfully, I don't need to do anything to these fractions because they all have the same denominator. So now I can have 12 plus 2, 4, 6/3. And then 6/3, remember, you could think of that as a division problem too. So 6/3 as a fraction is the same thing as 6 divided by 3. And 6 divided by 3 we know is 2. So technically I have 12 plus 2 right now, and 12 plus 2 equals 14, which matches my total that I started with overall, so I know that I got the right answer for this problem. So we've been slowly learning all these tips and tricks, and that's leading us up to dividing fractions like on our own using the numerical way, and then understanding how to solve all of these different problems. So today, what you're going to be doing for your problem sets is, remember, you're on lesson 4 today. You are going to work through number 1, A through D, and number 1, A through D is going to ask you to do mostly tape diagrams and then check your answer with this repeated addition. And then after that, you're going to do number 2, A through D, and it's kind of a chart that is similar to the one that you did for lesson 3. And then you're also going to be doing word problem number 3. Please make sure you're working on those word problems, because for your exit ticket tomorrow, you will actually be doing an exit ticket that is only a word problem. So make sure you're getting that practice with those. Then for your homework, you're doing number 1, A through D as well, number 2, A through D, and then word problem number 3. And again, make sure you're really focusing on how to solve those word problems. You could also do more if you want that extra practice. All right, so that's our video for today. I know it's kind of a long one, but thanks for sticking with me. And if you need any help, please make sure you ask. All right, good.